My name is Evan Tenley. I'm from the Met Office, and it's my very great pleasure to be helping present this together with some ARMETSOC people and the Royal Meteorological Society people in the background. And so we'll just go through a few housekeeping slides first before we go on to the main event of today. We've just a couple of adverts from the Royal Meteorological Society first. The first off is to advertise their WeatherClub, which is a something that you can register for, which has a website, and it gives you information about the events and meetings about the weather that are held. And there's a good opportunity to participate in some events like the Great British Weather Experiment and competitions, as well as to get unparalleled access to experts to talk about the weather. And there's a newsletter and things. You've got you can go down to the URL that's down in the lower left here and register if you want to join for that. As well, I should say that it's definitely worth registering to become a member of the Royal Meteorological Society because it's a fantastic society for anyone who's interested or involved in meteorology, and it's got a very wide range actually. It's as well as professionals and academics. There's also students, teachers, and enthusiasts and observers who really help contribute to make the society what it is. So you've got benefits with this. You get a monthly magazine, either physical or you can access it via an app as well or online. And you can get discounts for conferences and some of the paid for meetings. You've also got discounts on some of the journals and access to some support grants, which might well be interesting, especially for students. The URL, again, at the lower left here is where you can sign up to join to become a member of the Royal Meteorological Society, and I definitely encourage you to do that. Okay, so today we'll be presenting using the Royal Meteorological Society's Demio platform. So hopefully, well done, you've already managed to join. So that's the first thing. Just a couple of things that are very handy. One of them is that you should be able to see videos of me currently and Peter during that. Just below the video, there's a little black bar, and you can move that up and down to help increase the size of the slides if you want. The other things that are handy for this is you've got on the top bar that's shown in this picture here, you've got two little arrows facing away diagonally away from each other. That can help expand the PowerPoint slides. And next to it, you've got an arrow with a vertical bar. Clicking on that can hide the chat to also enlarge the screen. The chat is, you can then click on, there's a chat button that then appears. You can click on that if you want to ask questions to the speaker. You can post those at any time, and one of the helpful ARMETSOC admin staff will be tagging those so that we'll go through those at the end. So I think that's it in terms of the housekeeping for now. So without further ado, we'll go over to Peter Gibbs. So just very quickly, Peter is a meteorologist and a broadcaster who's had good number of years, I think over 30, isn't it, Peter, with yes. the Met Office as a forecaster, and then with the BBC as a presenter as well. So over to you, Peter.
Thanks very much, Edmund, and good afternoon, everybody. Looking at the chat box, I can see some very varied weather coming in from particularly around the UK at the moment. Cloudy skies here in Berkshire, which means that we're certainly not going to hit those very high temperatures that we saw yesterday. I suppose the current weather will probably figure in this event next year, understanding the weather of 2021, having had the hottest March day since 1968, with Kew hitting 24.5 degrees. We'll have to see if somewhere comes up with something a little bit higher than that today, where you have got the sunshine. Rather unexpected, I think, this bank of high cloud that's turned up here through today, but always interesting weather to be looked at here in the UK, and that's where we're going to have a look at partly, but also I'll be looking at weather events around the globe over the whole of 2020. So let's kick off with sort of a global overview, really. And well, 2020 was either the hottest or an extremely close second to 2016. Essentially, the 2 years really are pretty much tide in terms of average temperature. The error bars within each of the various data sets that are used to determine the figure are big enough to actually mean that the difference between the different data sets is not really that significant. So a very notable year once again. Particularly notable because it was actually a La Nina year towards the end of the year. La Nina, of course, has a cooling effect on global climate with an upwelling of colder water in the Pacific. 2016, the previous record warm year, was a strong El Nino year, which has the effect of warming the atmosphere from upwellings of warm water in the Pacific. So really a very notable result for 2020 to end up pretty well tied with 2016. It was convincingly the hottest on record for Europe, 0.4 Celsius above 2019's record. And there was certainly a very strong driving effect from land surface temperature, which is what was offsetting the slight cooling effect from that La Nina. So the land continuing to heat up quite remarkably. And 2020 also rounded off the hottest decade on record as well. And you can see the clear trend there. We're looking at differences from the pre-industrial era. Well, just a steady upward trend really from the 70s onwards, decade after decade, each one warmer than the rest. Notable though that the heat wasn't evenly distributed across the globe in 2020. I think what jumps out here on this graphic is that big red area across northern Russia, Siberia, parts of northern Europe, and onwards into the eastern Antarctic. There were some remarkable temperatures here, high 30s recorded in northern parts of Siberia. This is compared to the 1951 to 80 average, but really shows the continuing trend of Arctic amplification, which is the Arctic regions warming much, much faster than other parts of the globe, thanks, well, largely down to reduced sea ice, so more exposure of open water during the summer, which absorbs heat, which then leads on to less sea ice during the following winter, and so that period continues. But it's becoming a regular occurrence to see temperatures above 30 degrees above the Arctic Circle. That's certainly been the case over the last few years. Rather than having a look at sea ice concentration, I thought we'd have a look at it in a slightly different way and actually look at the Northwest Passage. The route, of course, from the Atlantic to the Pacific across North America, and looking at periods when the Arctic Ocean, that passage, has been open to shipping with 15% or less sea ice along that path from satellite records. And we're going back to the early 1980s here. And you can see that trend, the blue bars, longer and longer period through the summer months of the Northwest Passage being opened. And 2020 was the longest such period in that satellite record, with something like 3.5 months through the summer of that passage being open to, well, potentially even non-ice strengthened vessels. And that's becoming something that's being looked at, of course, very strongly now, and will probably become a regular feature with shipping using that passage over coming years as that trend continues. Looking at CO2 concentrations, well, they kept on going up. This is the record, the longest term record we have, which is from Mauna Loa, top of the mountain in Hawaii. And you can see that relentless upward trend in CO2. The zigzag line on that is interesting. That shows the waxing and waning of vegetation across the Northern Hemisphere. So during the Northern Hemisphere winter, as the vegetation dies back, it rots away, it releases some carbon back into the atmosphere, and the level peaks, usually peaks around about May time, before the new spring growth then starts to really get away and pull in carbon from the atmosphere and take the levels back down again. But on top of that trend, the overall trend is certainly upwards. Peaked at 417.3 parts per million. Remember that pre-industrial, we were at something like 280 parts per million. The worrying thing is that despite the pandemic and the huge reduction in human activity, annual emissions seem to be only down around 4 to 7% over the course of the year compared to 2019. And 2019 itself was actually a record year for emissions. So not a terribly hopeful message there. More encouraging news, perhaps, when we look at the UK, because 2020 did actually mark a milestone for UK emissions reduction. This study from Dr. Simon Evans at Carbon Brief found that the UK's greenhouse gas emissions in 2020 were 51% below 1990 levels, meaning the UK is now halfway to meeting that target of net zero emissions by mid-century. Interestingly, just a couple of days ago, that figure was revised. It was actually, they think now 49% rather than 51%. And that's down to some new research looking at peat bogs and emissions and uptake of carbon from peat bogs. And it seems that actually peat bogs are taking up rather less carbon than was hoped, largely due to poor management practice. So that has now moved the UK land sector from a net sink of carbon to probably a net emitter. And that's certainly something we need to address, I think, going forward. But nonetheless, it's a good milestone to have reached. Slightly worrying, emissions were only down 11% due to the pandemic. So it does show the magnitude of the challenge we have to achieve the remaining 50 or so percent to reach that 2050 target. So 2020 in the UK was the third warmest on record, those records back to 1884. It was the sixth wettest, those records back to 1862, and also the eighth sunniest, records there back to 1919. Worth noting, it's the only year in the whole of the record that is in the top 10 rankings for all those three parameters, so temperature, rainfall, and sunshine. And it's interesting to look at the way those parameters varied through the course of the year. It's a rather nice graphic here from the Met Office that shows that. So the top section of that graphic shows rolling 30-day rainfall totals. So the big green peak at the start is the extremely wet February, and I'll do a little bit more detail on that in a moment, which then switched almost overnight into an extremely dry and, looking at the bottom graphic, extremely sunny spring. So it was almost like somebody flicked the switch from wet to dry and sunny almost from 1 week to the next. It was an extraordinary change of weather regime over such a short space of time. And both of those change regimes actually caused their own problems. So let's look at the February rainfall first of all. And it basically came from a trio of pretty powerful storms, certainly the first two of them. Named storms, so the first one was Ciara, 8th, 9th of February. It certainly brought very strong winds. That notorious windy spot, Needles Old Battery, stuck out there on that exposed peninsula on the Isle of Wight. Winds gusting up to 97 miles an hour. Notorious wet spot, Honister Pass up in the heights of the Lake District. 177 millimetres of rain in 24 hours. It was one of the most powerful storms, Ciara, of the last few years. Widespread flooding, no surprise when you see those sort of amounts of rain. And West Yorkshire was the area, or one of the areas worst affected by the flooding. The reason for the storm, the first one, a very, very powerful jet stream blasting out across the Atlantic, 265 miles an hour in the core of the jet. That was caused by very strong temperature contrast, particularly in the upper atmosphere, between the polar regions and the subtropical air to the south. That was helped along by a very strong polar vortex. So this is the circular vortex that forms across the polar regions in winter time. When that's very strong, it holds the cold air in over the pole, allows that air to get colder and colder, and that then enhances the temperature difference, which is what drives the jet stream. Some interesting effects apart from storms as a result of that very, very strong jet, which is picked up by Paul Knightley, a Royal Met Soc member, very much involved in forecasting on the commercial side of things. Transatlantic cargo flight doing 793.5 miles an hour ground speed at its cruising height of 35,000 feet. Now, of course, it's not doing that speed through the air because that would be getting towards sort of supersonic speeds. But what is happening there is that it's got its normal overground speed at cruising height of around about 550 miles an hour, that sort of order. And then you're adding on to that the speed of the jet stream, which it's hitching a ride on across the Atlantic. So some rather early arrivals, I suspect, in Europe as a result of that jet and hitching that ride. So that was Storm Ciara. A week later, we saw Storm Dennis, and look at that central pressure on the chart there, 925 hectopascals, or millibars, if you, like me, tend to work in the old stuff still, after 30 odd years in the Met Office. Very, very tight isobars, of course, producing some very, very strong winds. No surprise with a storm of that intensity. It was actually one of the most intense extratropical cyclones ever recorded in the North Atlantic, and more rain on top of the saturated ground that we'd seen from the previous storm. A rare red warning from the Met Office was issued for South Wales. Absolutely classic conditions for feeder mechanism for producing enhanced rainfall across the valleys of South Wales, with that very moist southwesterly airstream being driven up through the valleys, the air ascending, and that enhancing the intensity of the rainfall. Worth mentioning, though, this storm was extremely well predicted a long way in advance. A week ahead, the models were picking it up very well. The warnings were going out, the early warnings. So even when it was just a little tiny depression over the southern parts of the USA, the warnings were already in place that this thing was potentially going to have quite a few impacts. And then the final one of the trio of February storms. I should mention the actual strong winds lasted over quite a period of days, because it wasn't just a single centre. You'll see the several centres keep forming to the north of Scotland and sort of rotating around each other, which kept the feed of very strong winds going. And still lots of isobars on the chart, even there, as you can see, 2 or 3 days later. 90 mile an hour gusts, so very strong winds once again, this time North Wales. And the amount of rainfall was pretty phenomenal when it was added to the previous rain from the previous storm. The rivers Wye and Severn actually got up to their highest ever levels, according to the Environment Agency. So let's move on to the final one of the trio, Storm Jorge, which was named by the Spanish Met Service this time. This one, not quite as intense, but still quite a squeeze in the isobars on the southern side of the low. Again, it brought quite a lot of rain, adding to the saturated ground, all the runoff from the previous storm, so more flooding problems as a result. And the overall effect of this relentless Atlantic activity gave the UK its wettest February on record. And in fact, across England and Wales, where the Met Office database goes even further back, it was the wettest in over 250 years. The chart you can see there shows percentage rainfall above the average. Large swathes, the majority of the country probably had twice its normal rainfall, but in parts of Cumbria, South Pennines, there were areas there that saw 4 times their normal February rainfall. So no wonder there was the results of flooding. Interestingly, Met Office climatologist Mark McCarthy has pointed out that in just over a decade now, we've had the UK's wettest February, wettest April, wettest June, wettest November, and wettest December. So new national rainfall records in 5 out of the 12 calendar months in just over a decade. And of course, that is consistent with some of the expectations of climate change. A warmer atmosphere can hold more moisture, and that then can result, given the right conditions, in more rainfall. But as we saw earlier, that pattern completely flipped as we moved into spring and as we moved into lockdown as well. It was the sunniest spring on record. In terms of English records, well, look at that chart on the left. 2020, almost 100 or just over 100 hours more sunshine through the spring months than the previous record holder, which was 1948. So absolutely extraordinary to smash a record by that amount. It was the sunniest April on record. May 2020 was the sunniest of any calendar month, so we're including summer months here as well. There's actually only 3 summers that have had more sunshine than spring 2020. That's 1955, the famous summer of 1976, of course, and 1989. As I mentioned, this all coincided with lockdown, which meant that those of us lucky enough to have a garden could actually spend a lot of time out there. But there had been some speculation that maybe as a result of lockdown, there was less aerosol in the air, pollution essentially, mucky particles for nuclei for cloud droplets to form around, and perhaps that was partly responsible for this extremely sunny spring. But I saw a paper came out just in the last week or two, which has concluded that that wasn't actually a significant factor. It was just down to weather patterns and the change in broad scale weather circulations. Not surprisingly, so much sunshine, it was also an extremely dry period. It was actually the driest May on record for England. 9.6 millimetres averaged across the whole of England, but there were some places that saw virtually no rainfall through the whole month. The second driest as well for Wales, which is, of course, very notable. Now, this caused a lot of problems for farmers because we had all that flooding back in February into the early part of March, just lingered on. So that really caused a lot of problems for some of the overwintering crops, things like winter wheat and so on, that just got completely drowned or washed out. So there was a lot of resowing went on during the spring once the ground was workable. But then we went into this dry spell. And so germination was very poor, growth was very poor. Grazing areas as well, farmers with livestock relying on grazing, the grass just didn't want to grow once that moisture had been stripped out of the surface layers by the relentless sunshine, and they were having to start digging into some of their winter fodder. So these big swings really do cause problems for quite a lot of people. So the reason behind that big switch, well, essentially very different weather patterns. Spring actually looked quite like a summer pattern in many ways, with the Azores high regularly spreading northwards across the UK. 1 or 2 weather systems just running across Scotland, bringing occasional rain here. But it was that persistence of high pressure that really made the difference. But it's interesting to look at the 2 seasons in terms of upper level winds. So we're looking at graphics here from jet stream level, average departure from average wind speeds at that height, winter on the left, spring on the right. So you can see the suggestion there for the winter months of the jet stream being absolutely smack bang across the middle of the UK for much of the time, bringing that very unsettled weather, regular weather systems coming in from the Atlantic. But then for the spring months, everything pushed away northwards, more suggestion of the jet stream being away towards the north, which then takes the weather systems northwards, of course, and puts us into a much drier regime. And that's exactly what happened. So moving on into the summer, relatively unremarkable in many ways. When you just add all the figures up, then it comes out as relatively average. But there were 2 notable exceptions, 2 pretty notable heat waves. And the first one of those came right at the end of July. July, actually, up to that point, was cooler than average. But then we set up this pattern with high pressure out to the east of the UK, low pressure to the west, pulling in a feed of very warm tropical continental air. And the temperatures absolutely rocketed, hitting 37.8 Celsius at Heathrow on the last day of the month. That's the 3rd highest temperature on record for the UK. almost a degree below the all-time record, which was set previously in 2019. But it certainly had the effect of sending people off towards the coast as we were out of the lockdown restrictions at that time, of course. And there was gridlock on many of the roads heading towards the south coast particularly. But I think it's really noticeable just how quickly this hot spell developed. Remember that July overall was cooler than average, but over the space of just 3 days at Heathrow, we went from temperatures just in the, less than 22 degrees, bang, 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 all the way up to almost 38 Celsius over the space of 3 days. And we've seen something similar with the very warm spell we're in at the moment across the UK. It's literally only taken 1 to 2 days for temperatures to get up to virtually record levels. This seems to be an increasing feature. Second heat wave, more prolonged spell this in August. Somewhere across the UK, 34 degrees was reached over 6 consecutive days. Not in the same place every day, but somewhere in the UK reached 34 degrees over 6 consecutive days. Again, a tropical continental airstream, as you would expect. This time, firm area of high pressure over Scandinavia, lows out to the west, frontal systems edging in now and again to western parts of the UK. But we saw temperatures 30 degrees or so spreading all the way up into some northern parts of England. How noteworthy is this? Well, we're kind of taking it for granted that we see 34 degrees in a summer now. But when you look back and think that over the 50 years between 1961 and 2010, there were just 7 occurrences of temperatures reaching 34 degrees. We've now had 7 occurrences of 34 degrees in 7 of the last 10 summers. So it's becoming a regular event. It's now more unusual not to reach 34 degrees in a UK summer than actually to reach that. So it's only when you look at those sort of comparisons, I think, that you see how much the baseline has actually shifted. So moving on to autumn, September was lovely. It was largely dry. There was a lot of warm weather around as well. But then into October, that changed with a bang, and we had the first named storm of the season, Storm Alex, which is actually named by Meteo France. Initially, the biggest impacts from this storm were actually further south, so hurricane-force winds across Biscay, huge amounts of rainfall pushing down into the Alpine regions, so southeast France, northwest Italy, houses destroyed, roads washed away, several fatalities as well. There's something like 500 millimetres of rain fell in the worst affected parts of the French Alps, which is around about 3 months of rainfall. The problems came for the UK because the storm became very slow moving. You can see over a couple of days it just sort of rotates around, slowly edges northwards, but the centre of gravity always to the south of the UK. But the fronts lying north-south becoming almost stationary, they became the focus for the heaviest rain, which reached a peak on October the 3rd. You can see the radar picture there on the left, sways of heavy rain across an unusually large area of the UK, and breaking records. So we ended up with the wettest October, with the wettest day on record, October the 3rd, the wettest day ever known across the UK, and broken by a considerable margin as well, those October records at a number of locations. I think the Oxford one you can see there is particularly notable. So it came out as an average of 31.7 millimetres across the UK as a whole. Previous record was August 1986 of 29.9 millimetres. But the Met Office worked out that came to 7.4 cubic kilometres of water, which is actually enough to fill Loch Ness and a little bit more. And actually thinking back to the early part of the year, February, 15th of February is the UK's 3rd wettest day. So in 1 year, we have the UK's wettest and 3rd wettest day. Okay, so a pretty noteworthy year all in all, I think, across this part of the world. So what was happening elsewhere? What was happening globally? Well, the Atlantic hurricane season has to be mentioned. It was the most active hurricane season on record. We had 30 storms reaching tropical storm strength and therefore becoming named. 13 of those went on to reach hurricane strength. 6 of those strengthened to category 4 or 5 to become major hurricanes. Reasons for the very active season, well, combination, above average sea surface temperatures in the relevant areas, and particularly across the Gulf of Mexico, and favourable atmospheric conditions off West Africa in the development region there, where of course we get these easterly waves, these areas of enhanced thunderstorm activity that run from east to west across Central Africa, move out over the tropical Atlantic, and if the conditions are favourable, can then form into tropical storms and onwards into hurricanes. You need light winds through the depth of the atmosphere. That's one of the main precursors to help that happen, and that was certainly the case. And that was helped along by the development of La Nina later in the year, which also tends to make conditions more favourable. To be fair, it had been predicted that it was going to be an above average season. Nobody predicted it was going to be a record season. So it started very rapidly. 9 named storms from May through to July. That was a new record. And it went on very late as well, well into November. 2 major hurricanes in November. That's the first time that's ever been recorded as well. Eta and Iota. And Iota was also the latest category 5 Atlantic hurricane ever known. The WMO ran out of names. The Miami National Hurricane Center, which is why they had to go into the Greek alphabet to the latter part of the season. They've decided that wasn't a terribly good idea. They've always had this as a backup, and they had to do the same back in 2005, which was the previous record Atlantic hurricane season. But there is potential for confusion. A lot of the Greek letter names sound quite similar. So it's been decided quite recently that the WMO is now set up another list of names, a list of reserved names, but names rather than letters, to be used in the event of going over the standard list. But yeah, an absolutely phenomenal season all in all. And worth focusing, I think, on those 2 major hurricanes that came at the end of the season in November, because they followed almost exactly the same track into Central America, just a week or so apart. Category 4 followed by an incredibly rapidly developing Category 5, hitting a very poor part of the world, of course, Honduras and Guatemala, and brought absolute devastation to some of those areas, which some of those places are still recovering from now. 4.7 million people affected at one stage by the combination of those storms. But they weren't the worst in 2020. Supercyclone Amphoon in the Bay of Bengal ran northwards into northeast India and across Bangladesh in May of 2020. It was the equivalent of a Category 4 hurricane. It's reckoned to be the costliest storm on record across the North Indian Ocean, around $14 billion worth of damage. 4.9 million people displaced, 2.8 million homes damaged, death toll 128, which, sad as it is remarkably low for a storm of this intensity in this part of the world. Of course, Bangladesh, extremely low-lying, very prone to storm surges from a storm like this. But it really points to the benefits of the improvements in weather forecasting and warning dissemination over the last decade in particular, that even a storm of this magnitude actually leads to relatively low death tolls. And then we move on to the Philippines and Super-typhoon Goni, which was in November, Category 5 equivalent this, and reckoned to be the strongest recorded tropical cyclone to ever make landfall anywhere in the world. sustained winds of 195 miles an hour. Sustained winds. So the gusts were actually stronger than that. I mean, in a climate like the UK's, it's just impossible to imagine what that must be like, a wind strength of 195 miles an hour. At least 32 people killed, but again, compare that to what happened back in 2013, similar intensity typhoon Haiyan, almost exactly the same track, very similar track across the Philippines, 6,300 people died in Haiyan. So again, that improved forecasting ability, that improved warning delivery, and being able to get people out of the way of these things and into shelter is making a huge, huge difference. Right, I'm going to move on to a different type of storm now. Not a revolving storm, but one that goes in a straight line, something called a derecho. And this brought an awful lot of problems to the Midwest during August 2020. Wonderful picture of the arc cloud there, a shelf cloud ahead of the approaching storm. But just the extent of this thing is quite staggering. An area of thunderstorms moving at 55 miles an hour across the Midwest, took 14 hours to travel 770 miles. Winds gusting up to 140 miles an hour were recorded, so certainly hurricane strength, and it ended up causing $11 billion worth of damage. A really, really vicious weather system. So what is a derecho? Well, it comes from the Spanish for straight. It's a straight line wind storm, which is associated with a fast-moving group of severe thunderstorms. So the thunderstorms develop into a line which is moving forward, in this case at 55 miles an hour. You've got very strong updrafts and downdrafts within that line of storms, and where those downdrafts come down in front of the storm, hit the ground and blast out forwards, you've got not just the strength of the gusts in that, but also added on to the movement of the storm itself, and that's how you can produce these very strong winds over quite a wide area. There'll be one or two tornadoes embedded in there as well, but most of the damage comes from these straight line winds. And you can see the sequence here. It's a radar sequence, so it's a composite image, so the thing moving from the left across to the right. So you can see quite a large area of storms developing originally across Nebraska, South Dakota, that sort of area, moving on through Iowa, which is where the worst of the damage was caused. And you can see the way it gradually extends southwards. So you see that straight line developing as it moves eastwards. That's the derecho effect with these straight line storms pushing across. But extraordinary damage. There's a picture there of a house with half a grain silo embedded in the side of it. Flattened crops on the right there. It's the most costly thunderstorm in US history. 1.9 million people lost power. Still offline, many places 10 days later because of the extent of the damage. One power company executive said it was like having a 40-mile wide tornado traveling 100 miles. The crop damage, though, was just remarkable. 6 million acres of crops in Iowa were damaged or destroyed, and it's estimated to have halved the crop yield across the state, which is one of the biggest arable producing states in the US. So yeah, still counting the cost of that one even into this year. Okay, I'm going to round off with just a quick whiz through mainly temperature events now. Now you probably remember end of 2019, extreme heat across Australia. Extreme wildfires as well. Well, that carried over into the early part of 2020. Hottest day ever recorded, January 4th, in the Sydney metropolitan area. That's sort of the equivalent of Greater London area, if you like. 48.9 Celsius at Penrith. That's 1.5 degrees above the previous record. But the wildfires didn't stop either. They continued into the early part of 2020. There's a study done by some Canadian researchers who looked at the smoke cloud from satellite pictures, discovered it was 3 times bigger than anything previously recorded in the satellite record. 1,000 kilometers across. It remained in one piece, essentially, for 3 months, traveled for 66,000 kilometers, reached a height of 35 kilometers. So it was on a par with the biggest volcanic eruptions of the last 25 years. And the amount of CO2 it emitted, 434 million tons, was about the same as 3/4 of the annual output of the whole of Australian industry. So it essentially doubled Australia's carbon emissions over a 12-month period. And some of the carbon, some of the black carbon, the soot that was carried by the cloud, actually fell out thousands of miles away over Antarctica. Talking of which, Antarctica wasn't immune from heat waves. We saw a new record for the Antarctic continent, which Argentina's Esperanza station just qualifies for that, as it's right on the very northern tip of the Antarctic Peninsula. 18.4 Celsius recorded on February the 6th. It's about a degree above the previous record. The Antarctic Peninsula is actually one of the most rapidly warming places on the planet. It's partly down to slow poleward movement of weather systems due to warming planet. There's also been an increase in the westerly circulation, the winds that just whiz endlessly clockwise around the Antarctic, which the increase in that has been partly actually down to the development of the ozone hole, which has increased the polar vortex during the winter months, which increases the low-level winds as well in that circulation around the Antarctic. So that effect may lessen to some extent as the ozone hole continues to heal, but the other factors pushing the rise in temperature are unlikely to change. I'm going to finish off with what could be a big headline eventually. Could be a new record high temperature for the Earth. So 16th of August, automatic weather station in Death Valley, California, Furnace Creek, recorded 54.4 degrees Celsius, just short of 130 degrees Fahrenheit. Now, if you do a quick Google, you will find there are 3 other temperatures reported higher than that. 2 of those are at Death Valley, and the highest of those is 56.7 in July 1913. There's a 55 that's reported at Kebele in Tunisia as well. That was back in July 1931. However, these 3 have been called into question by weather historian and ace weather record detective Stephen Burt from Reading University. So the World Meteorological Organization are looking at Stephen's findings of those previous 3 temperature records. They're also looking to verify this latest Furnace Creek temperature as well. So it's all a bit of a cliffhanger at the moment. That said, the wheels of the WMO do move exceedingly slow. So the suspense over this one might actually, I suspect, wear off. But what is undeniable is that it really is extraordinary, this temperature. When you look at the date, 16th of August, so it's a month on from those previous records. The sun is lower in the sky. There isn't as much power in the sun as there is in July. So an extraordinary figure to actually see. And, well, we'll have to see what comes out of those investigations. So I suppose we end really where we started, with a tale of rising temperatures. I hope you've enjoyed that whiz around the weather highlights of 2020. We'll see what 2021 comes up with, but there's certainly a lot I had to leave out from 2020. There was a lot more I could have talked about. I hope you enjoyed that.
Much indeed, Peter. I think we've got a lot of questions. We're not going to run out of those. So if I go over to those and then start off just in order of who's basically come first. So we'll start off with Sittel's question, who's asking whether we think that there will be higher temperatures for the next 5 to 6 years in the Northern Hemisphere.
I suppose it depends what you mean by much higher temperatures. The Northern Hemisphere is certainly showing the strongest warming currently, but that's because most of the landmass of the Earth is in the Northern Hemisphere. and the land heats up much more quickly than the sea. The sea's got a higher specific heat capacity, so it absorbs more of that warmth and warms up much, much slower. That's a bit of an issue, mind you, because it holds on to the warmth much longer too, and is actually starting to transfer some of that warmth down into the lower parts of the ocean. That's a trend that's really being picked up now, that lower parts of the ocean are starting to see temperatures picking up as well. So there's some natural variation that has to be overlain on top of the year-on-year variation, on top of the overall trend. So it's hard to say we'll definitely see much higher temperatures over the next 5 or 6 years, but the trend is very, very clear. So I'll be surprised if we don't see more high temperature records broken over that period. Certainly many more high temperature records are being broken than low temperature records.
Lovely.
Currently.
Okay, so then over to Kirsten's question, who's asking what role did the North Atlantic Oscillation or the Arctic Oscillation play over the last decades or years globally, and I guess also in the Northern Hemisphere?
That's an interesting one, because I did see a paper came out quite recently which was casting a little bit of doubt on just the veracity of some of these oscillations, these variations, whether really they could be down to natural variability rather than anything else, and whether we are picking up any sort of trends from it. It certainly plays a part, I think, in terms of European weather over the winter. That's our main driver, which is what we saw in when I was talking about in February, of course, that we had a very strong flow from west to east because we had a big temperature contrast from north to south, low pressure in the south, high pressure in the north as well, so everything being driven across the Atlantic. Other years that will switch and it'll be a much more blocked pattern because everything swaps around. But teasing out the natural variation in that from the underlying signal of climate change is one of the things that's still quite taxing and is still challenging climate scientists.
So that takes us kind of quite nicely on to John's question, who's asking about saying that El Nino and La Nina effects aren't always the main drivers, like he's looking at 2016 and 2020 for warm years, and wondering what other factors come into play. Now, I guess you've discussed the NAO or the Arctic Oscillation in terms of the European climate. I guess given the El Nino and La Nina, this may be looking at a more global scope.
Yes, I guess this is probably talking in terms of overall global temperature, I think.
My guess as well.
Because I talked about it, yeah. Okay, because I talked about it in terms of the Atlantic hurricane season as well, of course. What other factors come into play? That's a very good that's a very good question. There are so many natural cycles going on different time scales, on different geographical scales as well, and it's the interaction between those that actually gives us the year-on-year variation in climate. And if you can imagine sort of, some of them coming into sync for a while and then going out of sync again over these different time periods, sort of resonance, if you like, coming into play for a while and having a bigger impact. It is a very, very complex system. And you've got to think about upper air interactions as well, and upper air cycles. And some of that is linked into the 11-year sunspot cycle as well. That has an impact on temperatures in the stratosphere. So all these things come into play and will have a bigger effect some years than other years. But certainly El Nino is a very big driver because of the sheer scale of it. I mean, it covers virtually the whole of the Pacific from west to east. So that's an awful lot of, it's like lighting a very large fire underneath the atmosphere and shoving that heat back in, some of which will have been sort of taken down in previous years and then released back out again when you get that upwelling returning. So yeah, it's a complex picture.
So then the next one from H. Sheeran was asking an interesting one. I guess you could say this is out of scope for 2020, but maybe have a go anyway. Would you expect the current volcano eruption in Iceland, despite not having an ash cloud, to affect climate temperature as near as northwest Scotland?
Yeah, that's an interesting one. I suspect not, because it's quite a minor eruption. It is emitting. It's not emitting ash, but it will be emitting gases. It'll be emitting probably a bit of CO2, certainly emitting sulfur dioxide, which has the effect of cooling. Sulfur aerosols usually have a cooling effect on the atmosphere, but it's such a relatively small source, and there'll be so much mixing going on of the atmosphere, because Iceland gets a lot of weather, so there's a lot of wind blowing across that part of the world, and if you imagine a bonfire on a windy day, the way the smoke gets dispersed quite quickly and taken around. So I think with the amount of mobility in the weather we have over this part of the world, it's unlikely to have any measurable impact on
Just from a weather geek side, however, there was one of our forecasters posted some really nice footage from a webcam over Reykjavik, just showing a really nice pyrocumulus coming out of that. That was the
fantastic. Yeah, I mean, it's a fantastic tourist attraction, isn't it? Well, not that there are tourists there at the moment, but it's been great seeing the locals go there and sit and watch the spectacle. It must be marvellous.
So we've had a couple of questions about the effects, inevitably, of lockdown on all of this. So there's a couple. There's one from John Murrell asking about how much the sunny spring was due to the reduction in contrails because of the reduced air traffic. And Nick are very much asking the same sort of question, whether there's been, slightly, whether there's been any studies looking at the effect of the pandemic on via the reduced air traffic to then reduce the seeding for high altitude clouds.
Okay. There's an interesting article in New Scientist actually last week about contrails and trying to reduce them, and making the point that actually the way contrails work has a warming effect, because they are so thin that they let through most of the incoming solar radiation, the shortwave stuff, but block some of the outgoing long-wave radiation. So in terms of sunshine, they don't have a great deal of impact, unless you have an unusual day when there is a lot of moisture in the upper atmosphere, and so the contrails will actually thicken up. But that's relatively localized, usually over high traffic areas, because when you look at the map of the air lanes, they don't cover huge areas. Everybody tends to travel the same routes from one place to another. But contrails there most of the time are so thin that they will actually let through most of the solar radiation, which is what would be recorded as sunshine. So probably minimal effect. And that was one of the things that was looked at in the paper that looked at aerosol.
This is it. I was going to say that I'll try and chuck a couple of references in the chat, but my understanding was it's the aerosol one that people are thinking is as you say, is dominant. Right, anyway, yes. Back to these ones. So then Ken's asking whether there's any studies, I guess, that you've got at the tip of your fingers that you can think of that show objectively that weather extremes are becoming more frequent in the UK or globally. Interesting question. I don't know of any studies off the top of my head. No, I suppose it would also depend how you define the weather extreme, wouldn't it? Are we just talking about a new record, or are we talking about something that's way outside previous parameters? Because you could call a weather extreme a record strong hurricane, or a record extent hurricane, or a latest in the season hurricane, or you could call a new high temperature a weather extreme. So I think
I think the difficulty there is the definition of what you're actually looking at. I'm sure there are studies, certainly, well, there are studies, I can't think of one off the top of my head to sort of reference to, but there are certainly studies that have looked at the frequency of records in terms of, as I think I mentioned, how many high records in terms of temperature are being broken as opposed to low temperature records. That work has certainly been done, and not just on an annual or monthly basis, but on daily records as well, because they're big on that in the States. So that sort of work has certainly been done. I'm not aware of any others particularly addressing that.
Just as I didn't read it myself, but I think you might have done, did the carbon brief one that Mark McCarthy had done that you looked through, did that cover extremes at all? I can't remember.
I can't remember off the top of my head, Edmund,
I'm
afraid.
Next one, Rex is asking whether we think, so I guess crystal ball territory, whether climate change will prompt formations of medicanes, so Mediterranean hurricanes, near England or in the future.
Well, yeah, that's a really good question. And it was, again, one of the things I probably would have liked to put in had I had time. I think there was certainly one, maybe two occasions of a medicane that came up. Perhaps I should just briefly explain what that is. It's a hurricane-like storm that's been observed to form in the Mediterranean. It's a bit of a hybrid. There isn't quite the sort of material there to generate a full-blown big hurricane, but it's certainly a circular storm with a little hole in the middle that is all warm air, which is essentially what a hurricane is. And actually, we did see something along those lines last year in the hurricane season, which developed off the coast of Portugal and affected Portugal. It wasn't defined as a tropical storm or hurricane, but it was certainly on the cusp of those two. And the National Hurricane Center in Miami did designate it as such. Whether we can get that sort of thing happening in the UK, we can certainly get the remnants of those things getting here. Whether they and we have had, I'm trying to think when it was. We had one sort of hybrid storm that reached Ireland, which was the remnants of a hurricane that came across. Was it a couple of years ago, 2 or 3 years ago, and had a lot of the characteristics still of a tropical storm, but was in transition to more of a mid-latitude system. The difference being that a mid-latitude system has a mix of warm and cold air that is the thing that drives it, that generates the power, whereas a tropical storm is purely driven by heat processes. So it's just warm air. It's not two different air masses coming together. I guess there's a chance that these hybrids will certainly get close to the UK in the future, but we're always going to be on that cusp of getting into the regime of strong upper winds, which is what tends to rip tropical storms and hurricanes apart.
So just in the last few minutes, a couple of ones. So Isabella's got a couple of questions. One of the first one is, what causes the cold area south of Greenland when most of the rest of the Northern Hemisphere is heating? So I guess that's one of your first plots of that picture.
The cold blob. The cold blob. It's been a feature for a good few years now, and has been the subject of much debate and a lot of research. The consensus seems to be, as far as I can tell, I haven't followed it as closely as I could. So climate scientists would probably have a better answer. But there seems to be perhaps some influence of cold water coming off Greenland from the melting of the Greenland ice cap and spreading out across that part of the world. There may be some contribution from a reduction of the strength of the Gulf Stream. So there's less warm air getting up, warm water getting up into that part of the world. So, because that's an anomaly map. So it's showing how temperatures are compared to average. So it's not necessarily saying it's a cold area, but it's colder relative to what it was previously. But they seem to be two of the main factors that people are talking about as potential drivers of that, which is a concern, of course. Because that would if it develops further and becomes a very permanent feature, affect the larger scale circulation across the North Atlantic, with implications downstream to this part.
And so related, sticking with the Arctic, Gary's asking what the effects might be on the jet stream when the Arctic region is warming faster than areas further south, whether whether that's likely to shift the jet stream.
Yes, or weaken it, which again is a very active area of research. It was really interesting during the really severe cold snap that we saw across the States a couple of months ago, when they had record low temperatures across Texas. Normally you have a lot of people, climate skeptics, jumping in saying, well, look, how can we talk about global warming when we've got record low temperatures here? Which you're used to sort of answering. But it was interesting that there were also quite a few people coming in saying, no, this is because of climate change. This is because the jet stream's weaker, the Arctic's warming more, so there's less of a temperature contrast, so the jet stream's weaker, it wanders about more, and so you get more of these blocking occasions. Which also has to be challenged because the science at the moment doesn't support that. The science does show some correlation in the summer months between Arctic warming and reduced jet stream strength and increased blocking, which can lead to things like heat waves and droughts if you end up stuck under an area of high pressure for weeks on end, for example. There is no convincing correlation currently or mechanism that seems to apply to winter patterns and increased blocking in the winter. So that's a very active area of research, but currently we have to be very careful not to apply that same logic. It just sounds intuitively correct. It's very tempting to use that narrative, but it's just not supported by the science at the moment for the winter.
And on the science, we our standard baseline 1981 to 2010 climate averages are used. When do we think we'll switch from to the 91 to 2020 baseline?
Once all the quality control has been done to everybody's satisfaction, that's when it'll move on. I don't know what the timescale is for that, but climate scientists take this very, very seriously. You have to be sure you're comparing like with like. So a lot of work will be going into, because 2020 is not long finished. So they'll still be looking hard at the data to confirm that everything is as it should
Lovely.
be.
And then last question from Robbie. Our extreme weather events seem to be getting more regular. So we're getting lightning, funnel clouds, and even the odd tornadoes seem to have increased and impacted the UK. Is this something we can see, expect to see more of?
Thanks for the question, Robbie, and thanks for the comment there as well. I'm glad you enjoyed the presentation. You would sort of think so, wouldn't you? With more energy in the atmosphere, with more moisture potentially in the atmosphere, it would intuitively lead to more severe thunderstorms. But as always with weather, there are lots of factors at play. So, who knows, it may change circulations in an unexpected way so that we end up with air that's far too dry to produce the heavy storms a lot of the time. And this is why we have climate scientists working on this day in, day out, trying to pin these sort of things down and trying to refine the models that are used to get a handle on exactly this type of thing. I mean, interesting to talk about tornadoes. Tornadoes have always been around in the UK, and there's a lot more of them than most people tend to think. I have seen it said in the past that there are more tornadoes in the UK than there are in the US in a given year, which is probably quite a difficult thing to actually prove, but there are a lot more tornadoes than you actually think. It's just most of them are really quite small affairs and happen in places where nobody is actually affected.
Again, just one of the things I found interesting was, I think, from a few years ago, an article in Weather, just giving the deaths from tornadoes, because, you know, as ever, deaths are quite well recorded, and if it's from something unusual like one, you can see it going right the way back to medieval periods, I think, if from memory.
Yes. Yes,
so
yes,
that's got us to the end of the questions. We've got in the normal chat, we've got quite a few more people saying thank you for the fantastic presentation. So I think we'll just finish up and go to the summary slides, just to go on to some of the future events. So just to say that this talk will be published on the Royal Metsoc YouTube channel, and you can also find it on the RMetsoc website for the there's this archived events URL here where you can find this talk, and you'll get a link to the video there as well. So that's the same event page that you registered at, slightly different URL. And then just to advertise a couple of forthcoming ones. So there's a local centre meeting from the Met Office's Mark McCarthy, who was quoted in this presentation. And so that's looking at a nice title, How Much Rain? And so it's looking about what the UK average rainfall means, how these statistics are generated, robust they are, and how they fit into the other monitoring data sets that are produced at the Met Office. So do go along to that in a few days, on 6th of April. And then on the 10th of April, there's another meeting for anyone who's interested in meteorology as it applies to aviation. So there's, so Bob Lunnan and a few others will be giving a talk on weather for general aviation license holders. So just again, thank you very much from us all, Peter, and thanks to all who attended, and to the Royal Meteorological Society for hosting this and doing a lot of work in the background. Many thanks from us.
And thanks for all the kind words, folks. Thank you, I appreciate that.
Thanks. Bye, everyone.
Bye.